Find an equation in x and y that has the same graph as the polar equation. Use it to help sketch the graph of the polar equation. Well, the first thing I'll do is take the r minus 6 sine of theta that we have and subtract or add the 6 sine of theta to the other side. And now remember that the basic relationships we have to work with here are r times cosine of theta gives me x, and r times the sine of theta gives me y, and of course r squared is just x squared plus y squared. Now I have a sine of theta here, and if that was an r sine of theta, I'd be in better shape. So I'm going to multiply through by r in this equation so that I have r times r on the left hand side, or r squared, and I'll have 6 times r sine of theta on the right hand side. And now I can see that the r squared term can be replaced with x squared plus y squared, and the r sine of theta can be replaced with just y. So I'll have 6 times y on the right hand side, and subtracting the 6y gives me x squared plus y squared minus 6y equals 0, and I'm leaving some space here because I'm going to complete the square on that. So I can find the center of what's going to amount to a circle here in a minute. Completing the square involves adding 9 because I take half of 6, that's negative 3. The half of negative 6 is negative 3. Square that negative 3 and that gives me 9. So I add that to both sides. And then the x squared is here, and these three terms are a perfect square now. They are the square of y minus 3. So I can write y minus 3 quantities squared here. That equals 9. And what we see is the form of a circle that's been shifted up 3 units so that its center is at 0, 3, and its radius is 3 units because the right-hand side gives me the square of the radius, so the radius is 3. Now I can produce a sketch of the graph of this shape by marking the center at 0, 3, and using the fact that the radius is 3 units, so I'm going to go up and down 3 from there to get the largest and smallest y values on the circle, and I'll go to the left and to the right 3 units from this center to give me the leftmost and rightmost points on that circle, and I'll connect the dots in my best approximation to a circle here. So that's a sketch of the graph of the polar equation, as well as the sketch of the graph of this Cartesian equation, which is equivalent to the polar equation that we were given.